Okay guys, here's the lecture we're going to put together for section 4.2. We're going to be doing some long division, some synthetic division, and some of the properties that go with it. So for the first example, they want us to divide by long division. You guys may remember this from Algebra 2 or even Algebra, but I'll take you through an example. Okay, so x cubed minus 4x squared plus x plus 6. We're going to divide it by x minus 1. Now, one thing to remember inside of the division symbol here, we have to have every power represented. So if you have x to the third, you need an x to the second term, an x to the first term, and then a constant term. If there isn't one in the original, you need to put a placeholder. So for instance, if there wasn't a 4x squared, you'd put 0x squared in there, okay? And then we always focus on the first term of each of them. So if I take x to the third and I divide it by x, I get x squared. Okay? My next step is to multiply back. So x squared times x minus 1. X squared times x is x to the third. X squared times negative 1 is minus x squared. Then I'm going to subtract what's left, just like I did long division with real numbers. So x cubed minus x cubed is nothing. If that's not 0, you did something wrong, okay? This number's not correct. So make sure that we did that right. Negative 4 minus a negative, so that's plus. This is negative 3x squared. And then you're going to bring down the other quantity, okay? Let's focus on the first term again. So negative 3x squared divided by that x is going to be minus 3x. Multiply back down. Negative 3x times x, negative 3x squared. Negative 3x times negative 1 is plus 3x. We're going to subtract. Negative 3x squared minus negative 3x squared is 0. X minus 3x is negative 2x. Bring down the plus 6. Focus on that first term. Negative 2x divided by x is negative 2. Multiply back down. Negative 2 times x is negative 2x. Negative 2 times negative 1 is plus 2. Subtract all of that out, and you're left with 4. Okay? And so the way I'm going to write my remainder is plus 4 over x minus 1. Okay? Just going to grab the book here for these next couple of examples, but all right. So make sure you follow those steps. You got a placeholder if you don't need one, or if you do need one, and then this is how the top is going to be written out. Okay? All right, example 2, compute the quotient by synthetic division. So this is a little bit different. Synthetic division, I no longer need all of the variables in there. I'm just going to deal with the coefficients. So I've got 1x to the third, 3x to the second, negative 4x, and negative 12. And if I didn't have one of those powers taken care of, I would still put a placeholder in there, okay? And so then I set it up like so. I'm dividing by x plus 2, so you should ask yourself, what would make that 0? So if I put a negative 2 in for x, I'd get a 0, which means that's what I'm going to put out in front, okay? And the way synthetic division works is you bring down this number, and then you multiply. 1 times negative 2 is negative 2. And then you add those results. 3 plus negative 2 is 1. Multiply. Negative 2. Negative 4 plus negative 2 is negative 6. Negative 6 times negative 2 is 12. And the last column here, this is your remainder. So when I divide those two values, these are the coefficients of what's left. Now, if I take x to the third divided by x to the first, my result is going to be a power one less than x to the third. So this represents x to the second plus 1x to the first minus 6. And that's going to be your result for that synthetic division. Okay. All right, example 3, compute the quotient and check your answer. So I can use synthetic division as long as I'm dividing by something that has a power less than 1, so it's or less than 2, it's x to the first. Here's one where I need a placeholder though. So I've got 2x to the third. I've got 0x squareds, 3x, and 7. And I'm dividing by x minus 3. If I put a 3 in for x, I get a 0, so I'm going to put a 3 out front. Then I'm going to follow those rules for synthetic division. I'm going to drop the 2 down, multiply. 3 times 2 is 6. Add these up. 0 plus 6 is 6. Multiply again. 3 times 6 is 18. 18 plus 3 is 21. Multiply. 21 times 3 is 63. And add these up, and I get 70. Well, it turns out 70 is my remainder. Okay? So the way I'm going to write my solution, we went from cubed divided by a linear, so we're going to get a squared term. This is going to be 2x squared plus 6x plus 21 plus 70 over what I divided by. That's going to be your final answer. So synthetic division is a lot more efficient than the long division is. But with both of them, you have to remember to put that placeholder in there. So we didn't have an x squared term, we needed to put something in there for it. Okay, if you forget that, it'll mess everything up. Right, example 4, compute the quotient. Well now, since I'm dealing with an x squared on the bottom, I'm back to long division, you guys. Okay, so we're going to go 2x to the fourth plus x to the third minus 7x squared. I don't have an x to the first term, so I'm going to put 0x and then plus 3. And we're going to divide that by x squared minus 2. Okay? And we're going to go through the same process that we did before. So we're going to focus on the first terms. 2x to the fourth divided by x squared is 2x squared. Okay, multiply back down. 2x squared times x squared is 2x to the fourth. 2x squared times negative 2 is minus 4x squared. Okay, plus 0x cubed minus 4x squared. Okay, subtract down, that's 0. X cubed minus 0x cubed is x cubed. Negative 7 minus a negative 4 is minus 3x squared. Okay. Look at the first term. X to the third divided by x to the second is x. X times x squared is x to the third. X times negative 2 is minus 2x. And again, notice where I'm putting that. I'm putting it in the column with its like term. So there's really no x squared term there in the middle. Okay? So x cubed minus x cubed is nothing. Negative 3 minus 0 is minus 3x squared. 0 minus a negative 2 is plus 2x. Okay? So now I'm there. Look at the first term. Negative 3x squared divided by x squared is going to be minus 3. Multiply down. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2 is plus 6. And there's no x's in the middle. So when I subtract, these are 0. 2 minus 0 is just 2x. And 3 minus 6 is minus 3. And I can't take x to the first divided by x to the second, so that's my remainder. I'm going to write plus 2x minus 3 over x squared minus 2. Okay, and so that's going to be my final solution there. So make sure of your placeholders. The 0x here, we have placeholders in a couple of these columns. And only put expressions underneath other expressions that are like terms so that you can go ahead and subtract them. Okay? All right, the remainder theorem. If a polynomial p of x is divided by x minus c, we did that with synthetic division and long division. Using synthetic division, the remainder is equal to p of c. Huh. How was that applied? Let's look at a specific example. So if I want to find p of -5, old school, I can just replace all those x's with -5s and work it out, okay? The calculator can do this just fine. Honestly, that's a very good way of doing it. But to verify that the remainder theorem works, we're going to use synthetic division. We're going to put our -5 out in front, and we're going to see what the remainder is. Whatever the remainder is equivalent, okay? So 1x to the 4th, 3x to the 3rd, -8x to the 2nd, 5x, and -6. Okay? And we're taking p of -5, so we're going to put a -5 out front. Okay? And we're just going to work through our synthetic division. So bring down the 1, multiply. -5 times 1 is -5. Add these together, I get -2. -2 times -5 is 10. 10 plus -8 is 2. Multiply again, 2 times -5 is -10. -10 plus 5 is -5. -5 times -5 is 25. And 25 plus -6 is 19. Okay? So that's my long division, or my synthetic division. That 19 represents my answer. That's equivalent to putting the -5 in for x in all of those terms. So if I went -5 to the 4th plus 3 times -5 to the 3rd, etc., I would get 19. So that's how the remainder theorem can help us through that. Okay? The factor theorem now, if c is a 0 of that function, then x minus c is a factor. Okay? In other words, when I put a 5 in, if I get a 0 out, x minus 5 is a factor. Okay? And conversely, if x minus c is a factor, then c is a 0. Okay? So, use the factor theorem to determine if the following polynomials are factors. Well, if the remainder is 0, that means it's a factor. Okay? And so, we're going to go through and just do some synthetic division. So 3x to the 4th, minus 2x to the 3rd, minus 21x squared, 32x, and minus 12. And so I don't need any placeholders here. The first one, if I'm dividing by x minus 2, 2 would make that a 0, so I'm going to check that out. If I get a 0 for a remainder, then x minus 2 is a factor. So bring down the 3, multiply, and I get 6. Add these up, and I get 4. 4 times 2 is 8. Negative 21 plus 8 is 13. Negative 13, sorry. Negative 13 times 2 is negative 26. Negative 26 plus 32 is 6. 6 times 2 is 12. 0 for remainder. So that means because I got a 0 for remainder, x minus 2 is a factor. So use the factor theorem to determine if the following polynomials are factors. Part A is definitely a factor. Okay? Let's go back and try it for the next one. Okay, this time I'm dividing by x plus 1, so I'm going to put a negative 1 out in front because that's what makes that 0. Okay, bring down the 3. 3 times negative 1 is negative 3. Add those up and I get negative 5. Negative 5 times negative 1 is 5. Negative 21 plus 5 is negative 16. Negative 16 times negative 1 is 16. 16 plus 32 is 48. And 48 times negative 1 is negative 48. I get negative 60. Well, negative 60 is not 0. That one is not a factor. Okay? Let's do it one more time for the last one there. All right, so 3x to the 4th, 2x cubed, negative 21, 32. Okay, so you're probably asking yourself here, what do you put out in front? There's a 3x minus 2. What makes that 0? If you set 3x minus 2 equal to 0, you would get 2/3. Okay? And so that's what I'm going to put out in front. We're going to just go through the process. Yeah, you got to deal with some fractions, but you've got a calculator. You can work through it. So bring down the 3. 3 times 2/3 is 2. Add those up and I get a 0. 0 times that is 0. Add them up and I get a -21. -21 times 2/3, well, 3 goes into -21 7 times. 7 times 2 is 14, so -14. Add those up and I get 18. 3 goes into 18 9 times. 9 times 2, okay, I think I messed something up here. Bear with me for a second, you guys. Oh yeah, sorry. 3 goes into 18 6 times. 6 times 2 is 12. Okay, I'm good. So remainder of 0, which means that one definitely worked as well. Okay, so that's all they're asking. If you're trying to determine if something is a factor, then go ahead and long divide, put the number that makes that 0 out in front. If you get 0 for a remainder, it's a factor. Okay? A polynomial p of x has 3 zeros. X equals 3 and x equals plus or minus 2. Use the factor theorem to find such a polynomial. Okay? So the factor theorem says that if 3 is a 0, x minus 3 is a factor. If the square root of 2 is a 0, x minus the square root of 2 is a factor. If plus the positive version of square root or negative square root of 2 is a 0, then x plus the square root of 2 would be a factor. And what they want me to do at this point is to just multiply it out. Use your skills that we've learned before about foiling. So anytime I have conjugate pairs there where I have minus something plus something, if you guys remember that a minus b times a plus b is a squared minus b squared, we could just work that out. That x squared is just x squared. Square root of 2 squared is 2. Now we're there. And then I'm going to have to FOIL this out. There's no easy way around that. So x times x squared is x to the third. Okay? Negative 3 times x squared is negative 3x squared. X times negative 2 is negative 2x. And negative 3 times negative 2 is plus 6. Okay? So I think if I graph f of x equals x cubed minus 3x squared minus 2x plus 6, it's going to cross the x-axis at 3 and plus or minus square root of 2. So that's a good way to test your answer. If this is a test question and ask you to do this, write this down, put that in your y equals, graph it, make sure it crosses the x-axis at those places, and you're pretty confident that that's going to work. Okay? Example 8. Given that 2 is a 0, use the factor theorem to help find all of the others. Okay. Well, if I know 2 is a 0, I should be able to divide out and have 0 for a remainder. So I've got 1x to the fourth, 1x to the third, negative 10x squared, negative 4x, and 24. Okay? They say 2 is a factor, or 2 is a 0, so x minus 2 is a factor. We're going to put a 2 out in front. Okay? So we'll go through our synthetic division. Bring down the 1, multiply. 2 plus 1 is 3. 2 times 3 is 6. Negative 10 plus 6 is negative 4. Negative 4 times 2 is negative 8. Negative 8 plus negative 4 is negative 12. Negative 12 times 2 is negative 24. And as we expected, we got 0 for a remainder. So what we know right now is this is going to factor to x minus 2 because we know that 2 is a factor. And I'm left with, I went 1 degree down from the fourth, 1x to the third plus 3x squared minus 4x minus 12. Well, I'm not completely factored because this x to the third term can factor more. Well, we can factor that one by grouping, you guys, okay? So if I look at just those two terms, I can take an x squared out of that. And I'm left with then x plus 3. And I can take a 4 out of, or minus 4, let's do that. Out of that, and I'm left with x plus 3. Okay, running out of room, so I'm going to erase some of what's above it here. Okay, let's move this up. So then I've got an x minus 2. Both of these have an x plus 3. And I'm left with x squared minus 4. Well, if you guys remember, x squared minus 4 is a difference of squares. So I've got an x minus 2, an x plus 3, x squared minus 4 factors 2x minus 2, x plus 2. So that would be the completely factored version of that. Okay? And I think I'm going to leave it there, you guys. Look online to see what your assignment is for section 2, and good luck.